All right, good morning all. Well, we've started some design with regards to this mini project. Our intention is to implement kind of one Bustrip transport system. We want to create a system that enable both users, that is the passengers, to book seats right from home. Yes, I say right from home. Actually, I had wanted to use Java SE technology to implement this formally, but when you look at the system, in real sense, it needs to be online, web. So we're going to use Java EE technology, web, JSF, parentheses, Spring, Hibernate, all that to implement. But our main aim, or our main concern now is the database design. The book or project was written by somebody, actually, I don't even know the author. Maybe I will search. It's like a chapter I saw in internet. It's sort of, since it has been designed, sort of us to reinvent the wheel, let's just use the design, because the guy has really done a very good job with regards to the design he has done. Sorry, I think there's a need for me to magnify for you to see clearly. Right, this is the first thing in the one of the design for flow chart he has done. I want us to understand the system before the implementations. Let's take a tour on the system itself. This is what he has as a flowchart of passenger login. Of course, we're going to be modifying some things. The start, the login, and the end, right? But before end, when the passenger starts, when the application starts from passenger's system, he logs in. Then he carries out some activities, not just end. These are part of things we need to be actually correcting. And this is passenger's registration. Passenger registers this way. You register. After registration, it asks whether passenger register. If passenger register, actually this flowchart are not really correct. When you register, then you log in. Anyway, it asks questions. Are you registered? Yes. Login. All right, I understand what it means. If he's not registered, if he or she is not registered, then you register and then login. It's correct. It's correct. Then this is another thing here. Please, this book has been shared in the platform, in the WhatsApp. So please, you take note of the pages. I think this is from the index here, is page 23. This is passenger check trip. The passenger check trip after logs into the system. After logging into the system, he checks the trip. Passenger enters the location they want to board and get off from the boat and date of the trip. passenger clicks on search button. That is if that location, if that particular what they call ticket schedule or ticket, if it has been scheduled in the ticket, then you see. If it is not, maybe he checks for an alternative. So he logs in, he checks the availability of his trip. If it exists, the trip details, what it takes him to and fro, right? And then I think this we are supposed to take a kind of let's say a theory class for us to deal with these things. Let's continue with the database design. This, as I said, is all our design. I just saw it, and I think the guy has done a very good job. So let's use it for implementation. Instead of us to invent something, I think it will be easier for us to just. So this is the entity relationship diagram, the ER diagram for bus passenger tracker app. Look at what it has. Okay. So if you are able to perfect this, then your database design is done, and that's what we are doing today. It's from here he reduces it down to the tables of the databases, and then that's what we do. We are modeling. So if you check from here, this is the trip, this is the system or ticket, this is another subsystem, this is another subsystem, trip stop. Okay, so this ticket has, these are entities. All these are entities. If you want to understand it very well, these are like your fields. For ticket, must have passenger ID, ticket date, ticket price, ticket serial number, payment ID, trip ID. You see, if you understand this, then you can come up with a table called ticket, and all this will be used. Then it has a relationship. It has a relationship with payment as a subsystem. Then you have payment ID, payment what? I think we're going to take a class for this probably tomorrow or something. Let's continue with this. I want us to finish the database design, even though we are supposed to take that before the database design for us to understand it very well. But we've started the database design, and this is our design. This is our if you can say model. This is our model. We have created about 4 tables, right? 4 concrete tables. So we have driver, we have passenger, we have ticket, and then we have stop. Can you see what we have done right now? This is ticket, and ticket has all those entities were here. All those attributes are here, and we have captured them. Inshallah, I'm going to send I'll upload the video we have done for this. I haven't uploaded it because I'm thinking of maybe creating another playlist or something, or we'll just continue with our playlist Java for beginners, and then maybe anyway, I'll do something regarding it. So let's now continue. I think we stopped at this stop relation, stop table. So what is the next? This is entity driver, right? This is what? Passenger. Have you done passenger? Yes, passenger is here. Next is stop, and then next is what? Ticket. I think we haven't done ticket. That's the one we are supposed to start now. So let's create another one called ticket. From the database perspective, we've created a database and we named it Bustrip system, I think. Actually, we're going to use Java EE for this. So for those who have not done Java SE very well, do not panic. most of functionalities, how they are being written in Java EE or web technology is like same, only that there are some the differences are not much. The most difference is that the UI. For here we will be using web, while in Java SE it is Swing, JavaFX or AWT or something. So I want us to check on the system. We call it Bustrip system. And then I want us to see the tables. These are our tables and the relationship tables, right? The first relationship we have a table called driver, and we have a table called passenger, and we have a table called that means we have done ticket. Yes, we've done ticket, because that's the one on my. It's better that we have checked. Okay, we've done ticket. Okay, so if you check from our model here, passenger has ticket. It's a relationship, many to many. Many passengers could have many tickets, and many tickets will be assigned to many passengers, right? So because I may purchase more than one ticket in a single trip, depending on kind of the type of trip, where I'll be branching, where I'll be picking it up, continuing with the trip and all that. So we have tickets already. That's good. And as you can see here, we're mentioning that this is what foreign key. This is what passenger ID is what a foreign key. A foreign key here from where? Foreign key. This is trip stop ID. So this has to be from where? From stop. Is it? Yes. And what is foreign key? We need to explain all this in our theory class. But then before the theory class, we have primary key, we have foreign key, we have candidate key, and we have composite key. These are three keys, but for now let's talk about primary key and foreign key. Primary key is a unique identifier in a given table. For example, in this table we have a primary key called ticket ID, right? Ticket ID. This is a key for this table called ticket. It is the unique identifier for the table. But within the table, while mentioning the entities of the table or the attributes of the table, rather, we mention one attribute called trip stop ID. This trip stop ID happens to be a primary key in a different table. And the table is, I think, stop. Is it stop? Yes, stop. Look at it. Stop ID. It is a primary key here. Well, in another table, it is being mentioned. Since it is being mentioned in this table, while it is a primary key somewhere, then it becomes what? Foreign key. Foreign because this table will be referencing some things in another different table. That's why we call it foreign key. It refers identification number to assign to each payment date, and then to assign to each passenger, and this to each stop destination. Because if you are traveling, you need to know your starting point and end point. This is very, very, very essential. Otherwise, it's going to be like you just be looping. You be iterating. You have no starting point. Anyway, starting point must be there. Maybe you don't have end point. So that doesn't make sense really. So that is it. Let's continue. I think the next is going to be payment, right? Payment as something. Then we have payment ID, payment date, and payment method. Payment. Payment. So I'm going to create another table. I click on this table icon and click, and I double click it. When I double click, it gives me this. Fly magnify. Yusuf Kaduba, one it's not clear. projector bi abin nan ba a gani da kyau. Aha. Ya dai kamar yayi haka ne kuwa ku tashi duba na jin yayi ko. Right, so you give it name, payment. Please name your tables with small letter. I repeat, name all tables, give titles to your tables. Can you see here it is written payment with capital letter, but this is the documentation. It is not implementation. I repeat, don't make mistake of capitalizing or giving the table name with uppercase. Reason. Yes, reason. Or sometimes, or in most cases, or web applications, in a portal, whatever website. I'm talking about. I said this is what I said. Do not capitalize the table names in the DB design. Reason being that while hosting, you might be using, if you use Windows while the development is being carried out, you have no issue. But if you use Linux or Linux family, or Unix, whatever, Linux docs and all that, then there is issue. There is going to be an issue. Because if you capitalize the name of a table, Linux doesn't see it. There's going to be an issue, of course. Linux will not see it. So that's kind of error you'll be seeing that says table do not exist while it exists. So now the first thing is, I think, payment ID, right? Payment ID, it's going to be primary key, auto incremental, zero field, right? And I think here we do give 3, right? 3 digits for the zero field. You know, when you say zero field, it's going to give you 001, 002. Next is what? For his own case, he has given it he has given it VARCHAR. Actually, that's supposed not to be VARCHAR, because we'll be incrementing it. VARCHAR will not increment. Okay. So payment date and what? Payment method. And I think that's all. We don't use to write payment, or we don't use to call we only call the name of the table in just one field. That's our design, and we have to be consistent. So for date, it has to be date time. That is the data type, the domain, the data type. Date time, and it has to be null, not null. Should be that time. Let me check the default. then payment method, right? Method of payment, whether through bank, whether maybe using a card, that is your debit card or whatever. So we're done with this table, and then you click out, and when you click out, you close it, it saves, and payment table is here. Payment table did not reference anything, but maybe another table will reference it. So let's continue. I don't know why when I magnify my system becomes somehow. I think there's something I need to check. I don't used to enjoy it when I magnify. Trip. For the trip we have trip ID, trip time, trip from. Can you see what we're talking of? Trip destination. And then trip bus, plate number, and driver ID. Driver ID is a foreign key, so it has to be written the way it is. So it can reference, it can do the work of referencing. Sorry, let me remove this. I'm not having a hand. So now the system becomes okay. So we've seen this. Alright, that is a table called trip. So you click and double click the table, then you give it name trip, and then you check. The first thing is trip ID. I know it's tiny, I don't know whether you see trip ID. Then primary key, not null, auto incremental, zero field. Next is trip time, trip from, trip destination. This trip time is the scheduled time, the scheduled for the trip. For example, this is what he says, 21:30. You know, for travels, mostly we don't call local. We don't refer to local time. We do use GMT. Yes, that's. But we can use either, since it is a local something. Bustrip, it's local since it is not air or something. So trip time and trip from. Trip time. That means time. Not now. From. Not now. Okay, the time has to be date time. The date and time functions. Then destination. Then the bus plate number, and then driver ID. Not now. Driver ID. Not now. Right, so that's it. Sorry, let me check something from this payment. Okay, it's all right. Next is the trip stop ID. trip ID and stop ID. The trip stop, is it correct? Yes, trip stop. You see, you can use camel case, but the initial shouldn't be capital. Trip stop ID, not null, zero field, auto increment. Let it be 3. And trip stop, trip ID is a foreign key. It has to be the way it is, and stop ID is also a foreign key. Not null. Trip stop, right? Trip stop also? Yes, stop ID. Stop ID, not null. Auto increment. Right? Yes, I thought of this. I did not give it number of digits here. The length of the digits that could be padded. Alright, I think we're done. That's part of the implementations. So this is what we have on ground. Please let's quickly look at the relationship, and let's create the relationship, and then we create the database, and then we stop. By tomorrow we're going to discuss the actual project and then the technologies we are going to be using for the Java EE things. And please start revising your HTML, XHTML, JS, JavaScript, CSS, right? Yes, I think those ones are okay for now. So, trip. Let's start with payment. Please, do we have any foreign key here? In trip, driver ID, right? Of course, we need to know the driver who is going to drive, because we want to create an automated system. Everyone knows his schedule, the time he's needed, the time he's off, the time he's on duty, the time he's coming back, time he's traveling, and all that. So we need to know for a trip who does the driving, and we need to know the plate number, the car itself to be used. I think there are things here we will have to create when we start development. Actually, there are many things we will have to inculcate in here. Like nothing was done on buses themselves, right? There wasn't any registration on buses, is it? Yes, there isn't any. If there were, then this bus plate number would have been something that calls an ID that calls from that refers to a table for that, I think. So please let's check on this. So the driver, that means this table has kind of a relationship with what? With another table called driver, is it? So let's create the relationship. This is trip, and this is a table called driver. What kind of relationship is it? Let's think about it first. You know, we have many to many, one to many, many to one, one to many, one to one, many to one. Can a driver be assigned to many trips? Is it possible? Yes, of course. Somebody who drove from Maiduguri to Kano, for example, and from Kano to Abuja, and from Abuja to maybe let's say Benue. You know, one driver is being assigned how many trips? About 3 trips, which is very possible. And then many trips could be assigned to many drivers. Many trips could be assigned to many driver. One driver, right? Yes, as it is, many to many. So let's take it. Look at it here. This is many to many relationship. So driver has what? Has trip, right? So you click on the icon, click on the driver, and click on trip. So you've created your relationship. Look at how it is. Driver has trip, and trip has driver. Then in the payment, there wasn't anything here. And actually, this I think we'll have to think of creating association or something here, because we need to. Okay, let's check on this trip stop. Trip stop has 2 things here: trip ID and stop ID. Okay, so trip has what? It has trip stop, and trip has what? Yes, it has trip has trip stop, and at the same time trip stop has trip, of course. So trip has trip stop. One trip could have many stops. Is it possible? One single trip should have 1 stop. Is it? Unless if you are branching. If you branch, you have to stop it. I think it is 1 to many. 1 to 1, I think. 1 trip to 1 stop. 1 to 1. 1 to 1, like this. And trip stop ID, of course. The stop ID here, I think it's also going to be 1 to 1. 1 to 1, since it is 1 trip, 1 stop. You don't stop and then you stop again. When you stop or continue, you are not stopping, you are branching, maybe for one reason or the other. And is there anywhere payment? Yeah, this is what I'm looking for. I know this payment must be associated to a given table. And if I want to travel, what do I pay for? The trip, right? How? Via ticket, is it not? So there is something here in the ticket. Here, payment ID. What kind of relationship is it? One ticket has payment, ticket has payment, right? Is it not? Yes. Or payment has ticket. Which is which? Payment has ticket has payment, rather. Yes, for each ticket there has to be a payment for it, and I think it is 1 to 1. Yes. You see, when I hover, please let's understand this relationship. When I hover on the relationship, can you see what is happening? It is telling you, it is directly referencing to what connects them. The primary key there, foreign key here, right? Primary key in payment and foreign key inside what? Ticket. So this is what connects them. If I click on this, it tells me this is what connects them. Big in, sorry, I think there's something we did here. Like if you check for this trip, we'll have to do something. I talked about something with regards to the domain or data type. One has to be very careful. This kind of applications are applications that are actually expected to generate data, very huge amount of data, because many people will be traveling. One person could give you a lot of roles, somebody who is frequently traveling. So if you check the length of what we have used as data type, the int, MySQL int, let's quickly do that on Google. One has to be very careful. If you mistakenly assign something that could be exhausted on time, then your application will be calling for maintenance, frequent maintenance. And actually, that's not a good design. One has to really think while assigning data types to variables. Let's see MySQL int data types. Data types limit. Please look onto the something here. The small int gives the storage is 2 bytes. We know bytes, right? Bytes, organized collection of related 8 bits. Right? 8 bits gives you bytes, and one byte gives you 1 character. So this gives you 2 characters. That is the storage capacity. Maximum value for signed numbers, not unsigned, for signed numbers. Look at maximum value for small int. 1, 2, 3, 32,767. This, if care is not taken, within 6 months you exhaust this, or even 2 or 3 months, depending on patronage. Medium int, look at the value here. 1, 2, 3, 1, 2, 3, 8,388,607. Number of what? Number of ints given. Signed int. Now, int gives you this. 2 billion. How many are we in Nigeria? Around 200 million. If you times 200 million by 1,000, it's a huge number, right? 1, 2, 3. Right, this is a calculator. What is it? This it's run in trillions, right? Because how many digits do you need in trillion? 1, 12 digits, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is not up to trillion, but close to, right? Very close to. So now you see, that means if all Nigerians should be using your application 1,000 times, then this will be exhausted. But big int gives you this 2 to power 63 minus 1, which is a very huge number. Let's check this. Okay, it's supposed to be power, right? Correct? Where is correct? No, it's not. The carat is before 6, right? Let's say in thousands, right? I think this will work. Well, if you check, this is a very huge number actually. That's why in some cases we use big int. But the storage, if you check, the disadvantage is the storage. Your system will be somehow, look at it, it's 8 bits. And you know, when you are developing web application, you need to be very, very, very careful about one, your memory. Memory is very, very, paramount. It's the most important thing. Memory, because it talks about your speed, it talks about the performance of your application, it talks about the efficiency, the cost if you are hosting on cloud. So this I just brought this so somebody should be careful about how he selects. That's why in some some cases, like in ticket, if you look at it, millions of tickets could be generated within just a week or something. That's why I gave it big int. Big int here. For the trip, I'm going to give big int as well, and payment as well. And I think all the int should be big int, unless if maybe we are. So with this, you can't for you to exhaust it. It's going to be a long time. So we can do that, I think, and then we stop for today. This is the very good advantage of using kind of modeling tool like Workbench and others, like Generis and others. But Generis is having only one undo. That's the disadvantage for the community version. Actually, I prefer using this. You can easily come up with corrections and all that. So you check for big int. Okay, big int. I think we said 3. Sorry. Big int for this we've corrected, and passenger, let's use big int for all. So we'll be rest assured that for this to be exhausted, it has to take very long number of years. So that's it. Let's create Ford engineering. We save the model first. Save it. Then already we have the database there. But let me create Ford engineering. Let's see if it can update the tables that are not there. Ford engineer. Okay. Okay, trip. What's problem with the trip ID, trip ticket? Like there is problem here. Let me do again. Operations has completed with errors. Please see logs. The log says what? Error. referencing column trip stop ID and referenced column trip stop ID in foreign key constraints. Primary key trip stop are incompatible. Okay, so you see there's problem here. Okay, that they are not compatible. Of course, this should be big int, right? That's what the guy that's what he's talking of. That's what I converted to big int and I was trying to reference it. So you see, system corrects in fact, this is supposed to be varchar, not even, since it is a reference. We don't need giving it this, the trip stop ID. In there, it generates, here it only tools. Let's give it varchar 45. Show you 4 things in there. Trip stop ID. It's still complaining. Okay, let me give it the type. Trip stop ID foreign key. Let me critically look into this. Begin. Okay, I did not correct the primary key here to big int. Look, let me do one thing here. Let me drop it first. Like drop database. stop has trip stop. All right. Referencing column payment ID. Okay. Referencing column payment ID foreign key. Okay. Payment ID is big int. Okay. This I have to remove this. Then reference it again. It was done in int, not big int. Okay. So here ticket has payment, right? One ticket has one payment. I think even here there is going to be a problem. This ticket has stop. So let me delete this and do it again. Ticket has stop, many to many. Ticket has stop. And here also driver has trip, many to many. Driver has trip, many to many. And I think here as well, passenger has ticket, many to many. Passenger has ticket, many to many. Okay, I think we're done now. So you see, if you're doing this manually, there are things you may not probably, unless if you come to implementations. Okay, there is remaining one here. Trip stop and trip stop ID. Okay, beacon trip stop, beacon. Trip stop ID, but this is in big int. Trip stop and trip stop ID. Okay, let me check with this relationship. And see what will happen. Maybe during implementation we bring it back. This shouldn't be a bottleneck for us. In fact, some relationship you don't even need to define them here. Operation has completed with errors. Trip stop reference column, trip stop ID. Sorry, I want to just execute, so maybe later we check on this. So the video should not be lengthy. I will check later to identify the problem, what is happening in the DB, wherever. Because I can, okay, here, driver ID. It's between these two tables or three tables, the trip stop and trip stop. I'll check it later. But then this is our database. It has run correctly. So if you check the tables here, you find out that all tables are here. Okay, these are the tables and the relationship tables. You know, if you have many to many, there has to be a table where you store the foreign key or the primary key of each table. That is many to many. For example, this. For many to many, there has to be a kind of relationship table here. This relationship table stores only two keys. Primary key of driver table and primary key of trip table. Okay, for these two I will check. So I'll check and then I'll let you know what happened. something is happening there. Thank you for listening. This is where we stop. By tomorrow, as I said, we're going to talk about the theory behind the project and the technologies we are going